Understanding the rate of change of momentum, the conclusion. So whatever we saw experimentally, let's have a look at it as a whole. If an object is pushed or stopped slowly, the object will have less chance of getting damaged. If something is pushed or stopped slowly, the damage that we see is less, right? That makes sense, right? Alternatively, if object is pushed or stopped suddenly, the object will have a greater chance of getting damaged. That makes sense. If you have a car and if the car happens to stop by braking, nothing happens. But if you guys happen to, by chance, if someone happened to stop the car by hitting a tree, the damage is huge. That's it. This very basic commonsensical scenario is your first, your first conclusion. Second one is the change of momentum of an object is not only determined by the magnitude of the force but also by the time during which the force is exerted. The change of the momentum is not only determined by the magnitude of the force. How much force is not the only factor, but also the time during which the force is exerted. That is also a factor. Right? So we can mathematically tell that the change in momentum, let me write change as delta, right? I hope you guys remember this. This triangle structure is nothing but your change. Change in momentum is proportional to force. Capital F. Then what else? Change in momentum is proportional to the time for which this force is applied. Small t. Now, if I combine this to understanding, therefore, change in momentum is proportional to the product of force and time. Now, if I divide both the sides with t, we have change in momentum by t is proportional to force. This very representation on the left is nothing but rate of change of momentum. That's it. That very thing is rate of change of momentum. That is proportional to force. The above expression is the second law of motion. This very statement that rate of change of momentum is proportional to force is your second law of motion. That's it. See, we have seen this practically. We have seen this. You're seeing this mathematically. And this as a statement is your second law of motion. Right? We'll see the derivation again. We will see the numericals again. Not again. We'll see the numericals so that we understand things better. There are a few more experiments. With that, we'll come to a conclusion. Right? So, let's read the statement. The rate of change of momentum of an object is proportional to the applied unbalanced force in the direction of the force. What is this in the direction of the force? We'll understand this. I hope you guys understood the first statement, right? It's proportional to the force, as simple as that. More the force you apply, longer you apply, more the change in momentum, right? So this is your second law of motion. We'll understand this with more experiment, more derivation, and more numericals. Okay, in the next video, we'll understand what is this statement, the direction of the force.